NASA might have just designed an engine that could change space travel forever, an engine that doesn't need fuel, doesn't produce exhaust, and could, in theory, reach 99% of the speed of light. Sounds insane, right? Even crazier, it seems to break the laws of physics, and many scientists say it shouldn't work. But what if it does? Could this be the key to reaching distant stars within a human lifetime, or is it just another overhyped concept that will never leave the lab? Let's find out. Long before this new NASA engine made headlines, there was another idea that shook the scientific world, the M-Drive. A propulsion system so strange that it made physicists question everything they knew about motion and energy. The M-Drive, first proposed by British engineer Roger Shawyer, claimed to create thrust without ejecting any mass. No fuel, no exhaust, just microwaves bouncing around inside a sealed chamber, somehow generating movement. That alone should have been impossible. But then came an even bigger shock. Early experiments suggested it might actually work. In 2006, Shawyer's prototype reportedly produced a small but measurable thrust, catching the attention of NASA's EagleWorks lab. A team led by Dr. Harold White decided to test the M-Drive themselves, and in 2013, they claimed to detect an incredibly tiny thrust, about the weight of an eyelash. This should have been good news, right? Not exactly. If the M-Drive truly worked, it would break the fundamental laws of physics, specifically, the conservation of momentum. The backlash was immediate. Many physicists dismissed the results as experimental errors. But then, in 2016, something unexpected happened. The Chinese Space Agency announced they had been testing a similar device for years and even hinted at plans to try it in space. Yet despite all the hype, inconsistencies in the data made the M-Drive seem more like wishful thinking than a real breakthrough. And just when the world was ready to forget about it, NASA came up with something even crazier, the helical engine. While the M-Drive struggled to prove itself, another technology was already pushing spacecraft deeper into space: ion propulsion. Unlike traditional rockets, which burn massive amounts of fuel in seconds, ion engines work by slowly and steadily accelerating charged particles, or ions, to extreme speeds. The idea has been around since the early 1900s, but it wasn't until NASA's Deep Space One mission in 1998 that ion propulsion proved itself in the real world. Over time, these engines became the go-to technology for long-term space travel. NASA's Dawn spacecraft used ion propulsion to orbit 2 different asteroids in a single mission, something chemical rockets could never do. Even SpaceX's Starlink satellites use small ion thrusters to stay in position and avoid collisions. But despite their efficiency, ion engines have a major flaw: they are incredibly weak. The thrust they produce is so small that it takes months or even years to reach high speeds. That's why NASA has been looking for something better, something faster, something that could take us beyond our solar system. One possible solution? Nuclear thermal propulsion, NTP. Unlike ion engines, which produce a gentle push, NTP works by heating hydrogen fuel with a nuclear reactor, creating powerful thrust. This could cut the travel time to Mars in half, making space missions safer and more practical. The idea has been around since the 1950s, but only recently has it gained serious attention. NASA and DARPA are currently developing a nuclear-powered spacecraft under the Draco program, set for a test flight as early as 2025. Russia and China are also racing to develop their own nuclear propulsion systems, believing it could be the key to deep space exploration. But even nuclear propulsion isn't fast enough to truly change the game. That's where NASA's newest and most controversial idea comes in, the helical engine. What if there was an engine that didn't need any fuel? One that could keep accelerating forever? That's exactly what NASA engineer David Burns is proposing. His idea, called the helical engine, is based on a mind-bending trick from Einstein's theory of relativity. Normally, If you push against something inside a closed system, like a car seat, you won't move. But Burns realized that if the object inside the system is moving close to the speed of light, its mass actually increases due to relativity. So, in theory, if you accelerate ions in a loop at near light speed, you could create an imbalance in momentum, generating forward motion without pushing against anything. If this works, the helical engine could reach 99% of the speed of light, making interstellar travel a real possibility. Trips that would take thousands of years with today's technology could be reduced to just decades, or even years. But there's a catch. As exciting as the helical engine sounds, there's a huge problem. Many scientists believe it simply can't work. The biggest issue? It appears to break one of the most fundamental laws of physics, the conservation of momentum. This law states that an object can't accelerate unless something pushes or pulls on it. That's why rockets burn fuel, to expel mass in one direction and move in the other. But Burns's engine doesn't do that. Instead, it manipulates mass inside the system, which seems dangerously close to trying to create motion out of nothing. And then there's the energy problem. Burns's design would require an absolutely insane amount of power, 165 megawatts, just to generate a tiny amount of thrust. To put that into perspective, that's about the same power output as a small nuclear power plant, all for an engine that, at least in its current form, wouldn't be able to lift so much as a piece of paper off the ground. Plus, the engine itself would need to be 200 meters long and 12 meters wide, making it impractical for any current spacecraft design. It also can't work inside Earth's atmosphere. It requires the perfect, frictionless vacuum of space. But here's the thing, science progresses by challenging what we think is possible. The laws of physics aren't absolute, they are based on our current understanding of reality. And history has proven that what seems impossible today can become commonplace tomorrow. So the real question is, will the helical engine ever go from theory to reality? Let's step back for a moment and think about where we are today. Space travel, as we know it, is incredibly slow. Even if we pour trillions of dollars into building a spacecraft with the fastest conventional propulsion system, we'd still need thousands of years to reach the nearest stars. That's the single greatest obstacle standing between humanity and deep space exploration. We've solved problems like communication across vast distances, advanced robotics, and even landing on other planets. But speed is the one thing holding us back. Now, imagine if the helical engine, or something like it, actually worked. Imagine a world where we could cross the solar system in days, reach another star system in years, and explore the galaxy within a single human lifetime. Suddenly, space travel wouldn't be about sending probes and satellites, it would be about human exploration on a scale we've never dreamed of. Colonizing Mars? That would be just the beginning. The real goal would be traveling beyond our own solar system, discovering habitable planets, and maybe, just maybe, finding evidence that we're not alone in the universe. This is why NASA continues pushing the boundaries of what's possible. They know that even if the helical engine never works, the research could lead to new ideas, new discoveries, and maybe even new physics. After all, science isn't about accepting limits, it's about breaking them. So, is this the future? Will NASA's helical engine be the first step toward light-speed travel, or will it turn out to be another scientific dead end? Only time will tell. But one thing's for sure, humanity's journey into the stars is just beginning.